Okay, so in this lesson, we're going to graph basic quadratic equations that have this form. Now, this is a review from a previous course, but these are in the form where you can just easily use a certain points and use a t-table. Okay, so for example, suppose you want to graph y equal x squared plus 2. Now, these equations are quadratic. In the previous lesson that we looked at, that review, those were linear equations. So the graphs were lines. You're going to notice that these graphs, when you graph the points and connect them, you're going to get a parabola. All right, so when you graph the lines, you get a line. When you graph a quadratic equation, you get a parabola. All right, so what you're going to do here is you're going to use a t-table. And since y is already by itself, you're going to pick values for x and solve for y. And so if x is 0, I'm going to get y equal 0 squared plus 2. And remember the order of operations. You got to do the exponent before you add. So 0 squared is 0, and 0 plus 2 is 2. So I get the point 0, 2. If you pick 1, so I get y equal 1 squared. Notice I'm putting 1 in parentheses plus 2, just like I did 0. I put 0 in parentheses. 1 squared means 1 times 1, which is 1. 1 plus 2 is 3. So remember, when you're finding these points, remember these are solutions. So the solutions, when you graph an equation, you're graphing solutions. You're finding the solutions. So these are solutions to these equations. And just like when you did the previous lesson, there are an infinite number of these. Now remember, when we graph the line, we needed just 2 points. But we used 3, but all you needed was 2 points. When graphing a quadratic equation, you want to use more than 3 points, because you need to connect these as a parabola instead of a line. Alright, now let's choose -1. So if x is -1, I get y equal, make sure you put in parentheses, -1 squared plus 2. Now be careful when using a calculator. When using a calculator, you need to put -1 in parentheses. If you don't, you're not going to get the correct value for y. So make sure you put in parentheses. -1 squared means -1 times -1, which is a +1. And 1 plus 2 is 3. Alright, so let's do 2. So when x is 2, I get y equal 2 squared plus 2. So that's 4 plus 2, because 2 squared means 2 times 2. And so I get 6. And then if I choose -2, I get y equal -2 squared plus 2. So again, -2 squared means -2 times -2, which is 4, +4. 4 plus 2 is 6. And that's about all you really need, those 5 points, to draw the graph, because when you notice, you're going to get this. So if you plot the point 0, 2, so 0, 2 is here. And 1, 3 is here. So that's in the first quadrant. So remember, you go to the right one, up 3. And then we had -1, 3 as well. So -1, 3. We had 2, 6. 2, 6. Right here, 2, 6. And then we also had -2, 6. So 2, 6 would be here. And then -2, 6 would be here. And notice that this is a pretty big grid that I have here. So if you wanted to do another point, and now remember, all these are solutions. So these are solutions. So you're going to notice that this point here would not be a solution, just like our discussion in the previous lesson. That would not be a solution, because that's not going to be on the graph. It doesn't make this equation a true statement. So you're only graphing solutions. But if I wanted to do 3, I get y equal 3 squared plus 2. So that's 9 plus 2, which is 11. And if I do -3, I get y equal -3 squared plus 2. And remember, -3 squared means -3 times itself, so that's 9. 9 plus 2 is 11. All right, and so I'm going to get something that looks like this. Negative 3, 11, which is here. And, I'm sorry, positive 3, 11. And then negative 3, 11, which is here. Now, as we go through the one of the chapters that deals with graphing quadratic equations, we're going to talk about symmetry. So these quadratic equations have symmetry, but we're going to get into that in that particular lesson. And all you do is connect these as a parabola. Make sure it's a curve. This is not a line, it's a curve. So do the best you can with drawing that curve, and make sure you draw the arrow. Do the same thing here. And so when we get into that chapter or that section that talks about graphing quadratic equations, you're going to use the idea of symmetry to help you draw a better graph. So that's what the parabola looks like. And in this case, you see the y-axis goes right through the middle. That would be the axis of symmetry, but we're going to get into that later. But remember, in the previous course, though, you were told that the lowest point or the highest point, so remember it also can go down like this, would be the vertex. So this right here is called the vertex of this parabola. All right, so the vertex occurs at 0, 2. All right, and so that's all you do. So you're just going to plot some points in the t-table. And so it's a good idea for this case here, only for this, it's always a good idea to use these values for x. Okay? All right, so let's look at this one. Suppose we wanted to graph y equal x squared minus 4. Let's say we want to graph x squared minus 4. So again, we use a t-table. I'm going to use the same values for x. So when x is 0, when x is 1, when x is negative 1, when x is 2, when x is negative 2. And that's really all I need are these 5 points to get me to start drawing the idea of a parabola here. But if you want to do 3 and negative 3, you can. 3, negative 3. And notice I'm using integers. Don't use any decimals, because then you would have to approximate. You have to use your calculator. You don't need a calculator with these. So use integers. Notice these are integers for values of x. All right, so in this case, when x is 0, I get y equal 0 squared minus 4. 0 squared is 0. 0 subtract 4 is a negative 4. So I plot the point 0, negative 4. So when I plot the point 0, negative 4, remember since x is 0, you stay at the origin. Stay at the origin. And then y is negative 4, I go down 4. So here's the point 0, negative 4. Also, when we get into that chapter with quadratic equations, you're going to talk about the idea of translations. But all we're doing here is just kind of reviewing what you saw in a previous course. All right, now if x is 1, I get y equal 1 squared minus 4. So that's 1 squared is 1. 1 minus 4 is a negative 3. If x is negative 1, notice I'm putting whatever I'm squaring, whatever I'm substituting into x, I'm putting that in parentheses. So when x is negative 1, I get y equal negative 1 squared minus 4. A negative 1 times itself is 1. 1 minus 4 is a negative 3. When x is 2, now when we get into that section, see how for 1 and negative 1, we get the same y values? That's going to be the idea of that symmetry later on we're going to talk about. When x is 2, I get y equal 2 squared minus 4. 2 squared is 4. 4 minus 4 is 0. When x is negative 2, I'm going to get negative 2 squared minus 4. Remember, negative 2 times itself is a positive 4. 4 minus 4 is 0. So notice again, the y values are the same. That is going to be the idea of symmetry later on. And then when x is 3, I get y equal 3 squared minus 4. So that's 9 minus 4, which is 5. And then for negative 3, I get y equal negative 3 squared minus 4. Negative 3 squared means negative 3 times itself, which is 9. 9 minus 4 is 5. All right, and then I'm just going to plot those points, and you're going to see what's going to happen there. And then we're getting to the idea of translations. You're going to see how subtract 4 or adding 2 does to the basic graph of x squared. That's going to be the idea of translations later on. So 1, negative 3 is here. We also had the point negative 1, negative 3. So negative 1, negative 3 is here. So that's in the third quadrant. This is in the fourth quadrant. 2, 0, and then negative 2, 0. So that's on the x-axis. 3, 5, and then negative 3, 5. So that's here, and then that's here. And then you just connect the dots, make it look like a parabola, make it look curved, like this. Now don't make it come back in like this, so don't do that. Make it, remember these y values got to keep increasing like this. Okay, so and then do the best you can here, make it look symmetrical. And so you get something that looks like this. Okay? So notice when we did x squared plus 2, the vertex was at 0, 2. When we did x squared minus 4, the vertex is at 0, negative 4. Alright, now let's look at this one. Suppose we wanted to graph y equal 5 minus x squared. 5 minus x squared. Alright, now when we get into that section later on, see how the coefficient of x squared is negative here? That's a negative 1. We're going to talk about what that does to the parabola. See how these parabolas opened up? How they opened up? See, it opens up. And the reason for that is because when we graphed these quadratic equations here, the coefficient of x squared here is 1. That's a positive. That's a positive 1. So if this is positive, if this number right here is positive, in this case it's positive 1, the problem's going to open up. See how right here this is negative? It's going to open down. So you can see how that's going to look. So we're going to use this t-table again. I'm going to use the same values for x. So if x is 0, if x is 1, if x is negative 1, if x is 2, if x is negative 2, 3, and negative 3. And see what happens. So when x is 0, I get y equal 5 minus 0 squared. Make sure you put that in parentheses. 0 squared is 0, and then 5 minus 0 is 5. If x is 1, I get y equal 1 squared, 5 minus 1 squared. 1 squared means 1 times 1, so that's 5 minus 1, which is 4. If x is negative 1, make sure you put that in parentheses. 5 minus a negative 1 squared. Now be careful, don't say 5 minus negative 1 is a plus 1, positive 1. You got to do the order of operations. The order of operations says I got to square before I subtract. So negative 1 times a negative 1 is a positive 1, so that becomes 5 minus 1, which is 4. When x is 2, I get y equal 5 minus, in parentheses, 2 squared. Remember, you got to do the exponent first before you subtract. 2 squared is 4. 5 minus 4 is 1. When x is negative 2, I get y equal 5 minus a negative 2 squared. Remember, order of operations, you got to square before you subtract. Negative 2 times itself is 4. 5 minus 4 is 1. When x is 3, remember, notice how the y values are the same. That's going to be the idea of that symmetry. When x is 3, I get y equal 5 minus 3 squared. 3 squared is 9. 5 minus 9 is a negative 4. So notice that it's not always the case where the y values are positive. Sometimes they're going to be negative. If x is negative 3, I get y equal 5. I keep wanting to put parentheses here. That's 5 minus a negative 3 squared. Now remember, you got to do the exponent first. So negative 3 times negative 3 is a positive 9. Then you say 5 minus 9 is a negative 4. Alright, so now we're going to plot those points. I'm going to see what that's going to look like. Alright, so I'm going to get the point 0, 5, which is here. and then 1, 4, which is here, negative 1, 4, which is here, 2, 1, which is here, negative 2, 1, oops, which is here, 3, negative 4, which is here, and then negative 3, negative 4, which is here. Remember, all I'm doing is just taking these points here and then just plotting those, and now I'm going to connect them. And so notice how the parabola this time is going down. It's opening down. Alright, and do the best you can with graphing this, just like I'm doing. And so there's your parabola. It's opening down. Again, remember, it's opening down this time because the coefficient of x squared here is negative. That's a negative 1. That's the coefficient of x squared. Okay? Alright, so let's do one more. So suppose you wanted to graph y equal a negative 2 minus x squared. A negative 2 minus x squared. Alright, so again, you're going to use a t-table. And so we're going to use the x values of 0, 1, negative 1, 2, negative 2, and then 3, negative 3. Alright, so when x is 0, I get y equal negative 2 minus 0 squared. And remember, we do the exponent first, so 0 squared is 0. Negative 2 minus 0 is a negative 2. When x is 1, I get y equal negative 2 minus, in parentheses, 1 squared. 1 squared is 1. You got to do the exponent first before you subtract, order of operations. So it becomes negative 2 minus 1, which is a negative 3. When x is negative 1, I get y equal negative 2 minus, in parentheses, negative 1 squared. Make sure you put that in parentheses. Negative 1 squared is a positive 1. Negative 2 subtract a positive 1 is a negative 3. When x is 2, I get y equal negative 2 minus 2 squared. 2 squared is 4, so negative 2 subtract 4 is a negative 6. When x is negative 2, I get y equal negative 2 minus, in parentheses, negative 2 squared. So again, make sure you do the exponent first. Negative 2 times negative 2 is a positive 4. So it becomes negative 2 subtract 4, which is a negative 6. When x is 3, I get y equal negative 2 minus, in parentheses, 3 squared. 3 squared is 9. Negative 2 minus 9 is a negative 11. And then again, for negative 3, I get y equal negative 2 minus a negative 3 squared. Negative 3 squared is 9. Negative 2 minus 9 is a negative 11. And so now we're going to just plot those points. And I'm going to go ahead and do it on this one. Alright, so remember, this was the graph of... let's do this one here. Let's use this one. So this right here was the graph of y equal 5 minus x squared. And we're going to graph this one. Alright, so 0, negative 2, let's not use, I'm going to go ahead and use a different sheet. I'm sorry. So if I use a different sheet, and we get into transformations, we're going to use the same grid to do a couple of those just to show you about the transformations. Alright, so let's see, we had, so I'm just going to plot these points here. So 0, negative 2 is here, 1, negative 3 is here, negative 1, negative 3 is here, 2, negative 6 is here, the point negative 2, negative 6 is here, 3, negative 11 is here, negative 3, negative 11 is here. Alright, and so notice that the parabola is opening down, and the reason is because the coefficient of x squared is a negative 1. It's negative. It could be the negative 3x squared, negative 5x squared, but it's still negative. So if it's negative, it's going to open down, just like you're seeing. So you can learn more about that in another section. All right, and so just make it look symmetrical. And so in all these cases that we're drawing here, the axis symmetry is going to be the y-axis. So notice every one of those is going to be symmetrical about the y-axis. And that's all. And that's all we're going to do with these quadratic functions. Now, in a later section, these vertices, see how this vertex here is 0, -2? They're not always going to be on the y-axis, so some will be in different quadrants. Some will open down here, open down, some will open up, okay? So that's going to be when we get into the idea of transformations. Okay, so that should take care of this lesson. Now, one more thing I want to tell you, just keep in mind that whenever you're graphing these equations, whether it's quadratic, linear, whatever it may be, you're finding the solution. So you're graphing the solution. So these are the solutions to these right here. These are solutions to this equation. So if you look at this point here, let's say you want to look at the point right here, 2, -1. So notice 2, -1 is not on that parabola. So it would not be a solution. And it's not, because if you look at 2, -1, so if I asked you, is the point 2, -1 a solution to y equal -2 minus x squared, you should say no, because it doesn't lie on the graph. So if we just substitute these values into the equation, you'll see that it doesn't. So y is -1, and you want to see that's going to equal -2 minus 2 squared. Okay, so order of operations, so this side's -1. Now let's kind of figure out what this side is. 2 squared is 4. -2 minus 4 is a -6, and notice those are not equal. Okay, so that's why it would not be a solution, so that's why it's not on the graph. Alright, so that's going to take care of this lesson.